Welcome, video example 2, unit 2, chemistry 1B. We're going to predict the sign for the change in entropy for the following reactions. So the first reaction is this one here. And what we need to look at is what species we have and how we can determine the delta S. If we look at this, we see that the change in the number of moles of gas is only 1 mole of gas and no moles of anything else. So therefore, the value of the change in number of moles of gas is positive 1. And since the change in the number of moles of gas is positive, the change in entropy is also positive. Okay, the second example is this one, and we can do exactly the same thing in this case, where we look at the number of moles of gas. So we have 2 moles of reactants and 5 moles of products. So in this case, we do exactly the same thing. The delta N gas is a positive value. So since that it's a positive value, the delta S is also positive. All right. In this case, the third example of OH minus plus H plus going to water, again, we see that there is no numbers of moles of gas, but we need to then take the number of moles of individual species. So if we look at the number of moles of product, we have 1 mole of liquid, and in the reactants we have 1 mole of ions, of OH minus ions, and 1 mole of H plus ions. So if we do the change in the number of moles, we see that we have 1 mole minus 2 moles. Here is 1 mole minus 2 moles, and we get negative 1 mole. So therefore, since the change in the number of moles is negative, the delta S is therefore negative. Okay, we have some more examples. Let's try this one with dry ice to carbon dioxide gas. Now remember, dry ice is solid CO2 going to gaseous CO2. So in this case, the change in delta S must be positive because we're changing from solid state to gas phase, and the gas phase always has higher entropy than the solid phase. So in this case, delta S is positive. All right. What about water condensing on a cool window? Okay, exactly the same story here. What are we looking at? We're looking at a condensation, so that means it must be going from the gas phase to the liquid phase, and in this case we know gas always has higher entropy than any state lower than it. Therefore, in this case, delta S was going to be negative. All right. Then for this general reaction, reactant AB going to A plus B. In this case, we have a larger number of moles of product than we do number of moles of reactant. So therefore, delta S is going to be positive. If we add food coloring to a glass of water, we are then adding particles into more particles, and therefore the addition of extra particles to a system would cause the entropy to increase, and therefore the delta S is going to be positive. And then the last example, I think, is this one, where we've got a solid plus a liquid going to a solid. In this case, we look at the number of moles of each species. We see that we have 2 moles of product and we have 5 moles in total of reactant. So 2 minus 5 gives us negative 3. So therefore, the delta S is going to be negative.